Now we're going to take a look at the second method for factoring polynomials in the form ax squared plus bx plus c. Previously, we learned the AC method, but now we're going to look at trial and check, which is very similar to the unfoiling method that we learned earlier. Now, when we were factoring trinomials like this, we saw that generally the factorization is going to be two binomials. And before, we would have x plus one number and x plus another number. But we're going to have to modify that a little bit here, because if we have x plus one number times x plus another number, when we FOIL it out, x times x gives us x squared, but what we need is 2x squared. So because of that leading coefficient, because of that 2, we can't just write x and x for the first terms. One of them is going to have to be a 2x. So we modify this method by changing the x terms. If this was a 3x squared, for example, if it was 3x squared plus something, then it would have to be x and 3x. If it was 4x squared plus something, we'd have to be a little bit careful, because it could be x and 4x, but it could also be 2x and 2x. So basically, we need to look at the different ways we can multiply two things to end up with that leading term. In this case, 2x squared, the only possibility is 2x and x. So we know that those are going to be the first terms in each of the binomials. Now, the constant terms, when we go and FOIL everything out, we know they're going to have to give us a product of negative 12. But there's a lot of different possibilities for getting negative 12. It could be negative 1 and 12. It could be negative 2 and 6, negative 3 and 4, negative 4 and 3, negative 6 and 2, or negative 12 and 1. So there are 6 different possibilities for how to fill in the constant terms, but in actuality there's 12. Because if we put the negative 1 here and the 12 here from the first possibility, that's different than if we put the 12 here and the negative 1 here, because the first terms are different. So there's 12 possibilities, and this method is called trial and check because we've got to try different possibilities and check to see which one of them gives us 5x for our middle term. So if, for example, we decided to do 2x minus 1 and x plus 12, we know that when we multiply the first terms, 2x times x gives us 2x squared, and the last terms, negative 1 times 12, gives us negative 12. So that's the f and the l in FOIL. We need to check now if the outer and inner terms will combine to give us 5x. So the outer terms here, 2x times 12 is 24x, and the inner terms, negative 1 times x is negative 1x, and 24x minus 1x does not equal 5x, so we know that's not the right one. And so we can continue. We can try and switch them. 2x plus 12 times x minus 1. And in this case, the outer terms, 2x times negative 1 is negative 2x. The inner terms, 12 times x is positive 12x. When we add those up, we get 10x, which is not what we're looking for. So that is also not going to be the right answer. Now, this seems like a lot of work because remember, there's 12 different possibilities. There's these 6 possibilities, and each one gives us 2 different ones because we could switch the numbers. But there are ways to eliminate possibilities, to narrow things down more, and when you get practice with this, it gets a lot quicker. So the first trick I want to mention is that this 2x plus 12 that we have here, this could never actually end up working. And the reason for that is because 2x plus 12, there's a GCF here that we can pull out. And since there was no GCF in the original polynomial, we can't have any factors that have a GCF that could pull out. So that eliminates more or less half of the possibilities, because a lot of these would pair something that's divisible by 2 with the 2x. So we can eliminate a lot of possibilities here. So let's continue and see if we can figure it out. So we've got 2x and x. Now if we look at this negative 2 and 6, neither of these are going to work, because if we put a negative 2 or a 6 here, both of those are divisible by 2, and we're going to have a GCF when we know we shouldn't. So we can get rid of those. Those aren't going to work. If we've got the negative 3 and 4, we can pair the negative 3 with the 2x. We couldn't pair the 4 there because that would give us a GCF. So here we've got 2x minus 3 and x plus 4. When we look at the outer terms, 2x times 4 is 8x, and the inner terms, negative 3 times x is negative 3x, and 8x minus 3x is 5x, which is exactly what we wanted, so we know that this is the correct possibility. One more strategy that people often use is looking at how big the coefficient is on the middle term. Here, 5 is not very big compared to this negative 12. So when we've got smaller coefficients in the middle, we often want to pick smaller numbers. If we were to have a very large coefficient in the middle, we'd probably want to pick a pair that has a larger number. Because if we look at this 12 and negative 1, the two ones that we did, we ended up with a 23x, 23 is pretty big, and then a 10x, and 10 is also fairly big compared to 5. So in general, one strategy is that when the coefficient in the middle is large compared to those other two coefficients, we generally are going to want to go with the factors that have a larger number. And if it's not that big, we often want to go with the factors that are closer together and a little bit smaller. With these sorts of problems, the best way to get good at them is to just get practice.